In this lecture, we will find out SOP form and POS form for the function y. I have already made the truth table. There are 3 variables a, b and c, and corresponding to all these 8 combinations, I have written the output. Y is 1, 0, 1, 1, 0, 0, 1, 1. Now instead of having this truth table, this information about y can also be given in the form of minterms or in the form of max term. So let's see how we can have it. If I want to express this information in terms of minterm, then I have to write all the variables inside this bracket a, b, c, and remember you cannot change the sequence. If a is written first, then b, then c, then you have to follow this sequence, because when this question comes in exam, there will be no truth table, and this sequence will tell the student that how the variables are placed in the truth table. So don't change it, and then we will use summation small m represents the minterm, and minterm is always written when the output is high. So let's see for what cases output is high. It is high for the first case, then these 2 cases. This one is m0, this is m2, this is m3, and for the last 2 cases the output is high, and they are m6 and m7. So 0, 2, 3, 6, 7. So we have 0, 2, 3, 6, 7. So by this information only, we know that the output is high for m0, m2, m3, m6 and m7. So for what values output is low? It is very easy. Whatever value is not present in this will yield the output equal to 0. So it is 1, 4, 5. 1, 4, 5 is not present here. So we can also express it in terms of max term. So let's see how to do that. A, B, C equals to pi. We will use pi. Then capital M stands for the max term, and in bracket we will have 1, 4, 5. Now this will tell us for 1, 4, 5, we have the output equal to 0. You can see it is M1, this one is M4 and this one is M5. And we have already discussed min terms and max terms in the last few presentations, so no need to explain it here. So let's start with the SOP form, And in SOP form, if a variable is 0, we write it as a complement. Let's say the variable is a and it is 0, we write it as a complement. And if the variable is 1, we write it as a. So this is a very important thing. You must know this before solving for the SOP form. So let's start with it. What we want? We want this function y to be represented as the SOP form. So we will write y on the left hand side, and as I am taking y, I have to see for the cases when it is high, because if y is there, it implies that it is 1, and if y complement is there, it implies that it is 0 in case of SOP form. I have already explained it here, and I want y, so I will consider all the cases when it is high. No need to take y complement, because in that case you have to consider all the cases when it is 0, and you have to again take its complement by using the De Morgan's law, and it will just increase your load and you will need extra time for it. So no need to do it, just go for the values for which it is 1. So for the first case, you can see a is low, b is low, c is low, so it is simply a complement. Or for the next case, when y is high, you can see a is low, b is high, c is low. So a complement and b and c complement. And for the next case, when it is high, we have a as 0, b as 1, c as 1. So we have a as 0, b as 1, c as 1. And for the last 2 cases, we have a, b, c complement or a, b, c. Now this is very important part of this lecture. This form we call as the canonical, SOP form. This form is called as canonical or standard, and in this each minterm will have all the variables in normal or complemented form. There are 3 variables a, b, c, and in first minterm we have a complement, b complement, c complement. So all the variables are present in the complemented form. Similarly, in the next minterm, we have a complement, b, c complement. So a and c are present in complemented form, whereas b is present in normal form. And the same way you can check for the other minterms also. So this is called the canonical SOP form, and we can use Boolean algebra, K-map or any other reduction method available to us to find out the minimal SOP form. We are going to reduce it, and you have already learned the reduction by using the Boolean algebra. So we are going to use Boolean algebra in this. Let's do it quickly because we have to solve for the POS form also. And you can see in the last 2 terms AB is common, and in this 2 we have A complement B as common. So let's take it common by using the distributive law. I have A complement, B complement, C complement from here. or I am taking A complement B as common, and in bracket I am left with C complement or C, and from the last two terms I have AB, in bracket I have C complement or C. Now you very well know that C complement or C is equal to 1. So I have A complement and a B and a 1. The C complement or C is equal to 1. In the same way I have A and B and a 1. Okay, let's try to minimize it further. And again in the last two terms you can see B is common. So let's take B as common, and in bracket I am left with A complement or A. A complement or A is again 1. So we are having A complement, B complement, C complement or a B. Now the very important point comes. We have to use the distributive law again to minimize it. And you remember, if we have A or A complement B, it can be written as A or B. We have to just omit this A complement. You can also prove it by the distributive law. It is A or A complement and A or B. A or A complement is 1, so we are left with A or B. So here we can apply this distributive law. Let's say X is equal to A complement C complement. So A complement C complement can be written as X. So we are left with X and B complement or a B. Now from here you can see I can eliminate this B complement and I will have X or a B, and it can be written as A complement C complement or a B. So this one is the minimal SOP form. Okay, this one is the canonical SOP form and this one is the minimal SOP form. We are calling it minimal SOP form because in each minterm, this is minterm, this one is minterm, we don't have all the variables in normal or complemented form. Here you can see B is absent, here you can see A and C are absent. So all the variables are not present, hence it is minimal SOP form. So this is all you have to do in the SOP form. Now we can move to our POS form. Let's solve for the POS form. And for POS form, if a variable is low or 0, we write it as A. Whereas if a variable is 1 or high, we write it as A complement. So we have just inverted our convention. In this case, we have A complement when it is 0 and A when it is 1, whereas in this case we have A when 0 and A complement when 1. So we have just inverted the things. So let's just try to find out the POS form for the function y. Let's do it quickly. Y is the left hand side and we are taking y. It means we have to see for 0. You can see from here, if we take y, we have to see for 0, and we have 0 for the 3 cases. I am highlighting them. For the first case, you can see A is low, B is low, C is high. When A is low, we have to write it as A. In the same way, B or C complement. Okay, and for this case, we have A as 1, B as 0, C as 0. So A complement or B or C. And for the last case, we have A as 1, so A complement, B as 0, so B, and C as 1. So I will write or C complement. So this representation is the canonical POS form. It is directly written from the truth table and we have all the variables involved in the max term. These are the max terms and you can see A, B, C whether in normal or complemented form is present. Now we will again use the Boolean algebra to minimize it. I will do it quickly. You know the Boolean algebra better than me. So let's use Boolean algebra. And you can see in the last two terms, A complement or B is common. So I will take it common. And we have A complement or B or C and C complement. This is from the distributive law. C and C complement is equal to 0. So we are left with A or B or C complement. And if this is X, so we have X or 0 and X or 0 is equal to X. So I have written A complement or a B. Now again a B is common. So we have to use the distributive law again. B is common. So from distributive law we have B or A or C complement and A complement. Let's open this bracket and we have A and A complement or A complement and C complement. A and A complement is 0 and we are left with B or A complement and C complement. Now you can see this is not the max term. We have to use the distributive law again. This is why we have to use the distributive law again, and we have A complement or B and B or C complement. So this is the minimal POS form. And I'm calling it minimal because in the first max term C is absent and in the second max term A is absent, whether in the normal or complemented form. There is no C or C complement, and here there is no A or A complement. So this is all for this presentation, and if you're just landed in this lecture, then there may be some doubt in your mind. So please go back and watch the last 4 presentations. Everything will be clear. It's just the example part. I have not explained everything. However, I have explained, but not completely. I'm just assuming that you have already studied the last 4 presentations, and I'm just solving one example.